Okay. This is pre-calculus notes on section 5.3, applications of exponential functions. Today's lesson is on, hold on, wait for it, compound interest.
Yay.
Yay. This is period 2 on January 30th. Everybody in this classroom has been informed that they are being recorded. Anything that you say can and will be used against you. Okay?
Recordable.
Alright, so, you're going to love this lesson. This is really easy. It's really applicable to your life. Okay? It's about how do you find either the amount of money that's in a savings account that's being compounded over time, or how much money do you owe if you take out a loan, okay, and that interest is compounded over time. The same formula works for both, okay? And then today's lesson is going to extend next week into something that is much more advanced. So today's kind of easy. Monday we'll take that further. Here we've got a word problem. If P dollars is invested at interest rate R expressed as a decimal per time period T, then A is the amount after T periods. And that's the formula that's given here. Make sure you have all of that in your notes. We're going to go on and we're going to use that formula in the next problem. All right, I'm going to pause this and wait for you to write all of this down. All right, so what we're going to do here is we're just going to, first of all, identify the values of everything I know. My unknown here is A. Okay, A is what we're solving for. So we don't have to manipulate this algebraically. It's just very simple plug in, and then simplify. So P stands for principal. Principal is the amount of money that you start with in the account. 8% is the rate. Now you have to change the percent into a decimal. Annually, again, I already said it a few minutes ago, but I'll say it again for the purpose of the recording. Annually means that we can use this simple formula that I've already shown you. There's a more complicated formula for when we compound more often than annually. Annually means once a year. And T is how long or how many years it stays in the bank, so T is 5. Okay? So all we're going to do now is we're just going to plug these in. And then we're going to use a calculator. Now, you need to carry a lot of decimals. When you take a number that has 2 places after the decimal, raise it to the power of 5, you've got a lot of significant digits that you've got to carry in your memory, all right? You cannot crop this off or round it until the very, very last step. So make sure that you're capable of using your calculators and storing all of that, all of those figures in memory. And I'm going to show you how to do that as soon as my calculator comes up. I'm going to pause the video. All right, so here's how I'm just going to, this calculator is very capable of keeping your order of operations just so long as you're paying attention to where you need your parentheses. All right, so I'm just going to plug in 1,000. I'm going to do it all in one line so I don't have to worry about rounding. The calculator is going to keep track of every significant digit it's capable of keeping track of. Okay. So if you leave this money in the bank, $1,000 in the bank for 5 years at an interest rate of 8%, compounded annually, $1,469.33. You're rounding to the nearest penny, but you can't round until all of the calculations are completed. Easy enough, right?
Easy enough.
All right, so now I'm going to show you problems where we're going to compound more often. Alright, so here we've got the formula underneath the one that was given to you on the previous screen, where we've got the value of n, and n stands for how often the compounding happens each year. Let me write that down. N is how often compounding happens each year. All right, make sure you have all of this in your notes, and then I will demonstrate this problem in a second. All right, so we already know what the principal is, what the interest rate is, and what the time is. None of that has changed since the previous problem. What's the value of n?
3.
You were right the first time. 4. Okay. Quarterly, like a quarter. They're $4. 4 quarters and $1. All right. Anyway, yes, quarterly, 4 times a year. Everything else is the same. Principal is 1,000, and rate is 0.08. And time is 5. Okay. Should the amount that we get be more or less than the amount on the previous screen?
It will be more.
It will be more, okay? Because compounding means that you're getting interest on your interest. So if we're compounding more often, the amount has to go up. All right, so 1,000 times 1 plus 0.08. This time we're going to divide that by how often we compound per year, and then we're going to raise it to the power of n times 5, 4 times 5, which is 20. All right, again, this is just a calculator thing. Using your parentheses correctly. The calculator knows the order of operation, so it knows to divide 0.08 by 4 before that's the add. 20. So now we've got 1485.95, which is in fact more than when we only compounded once a year. 1485.95. All right, there's 2 more problems on this slide, on these slides. Let's see. Are you ready to start doing problems by yourselves yet? So the only thing different about this problem is that we are doing it monthly. So what's n?
12.
12. All right, and then I'm going to split screen this. And so weekly will be what?
52.
52. Do you want to try them? And then I'll do my work in a minute. Oh yeah, pause the video. Thank you. Okay, so those are my solutions. Check your work and ask questions. All right, that concludes that video.
Peace.